Alright, in this video I'm going to go over number 36 and 37 from the homework due last Thursday. Yeah, I'll walk through these problems. The answers you see here are in point slope form, in standard form. They don't need to be. For some reason the book put them in this form. You can put them in any form you want. I don't care. So problem 36 is asking to find the equations for the three medians of this triangle, triangle QRS, and then find the intersection. Show that they all meet at the same point, at the point 2, 4. So the first thing you want to do when you're trying to find this, I'll make this a little smaller here. The first thing you need to do is to find the midpoints of the three sides. And by the midpoint formula, which is just averaging the x's and averaging the y's, you find that point C has the point 6, 6. Point A has the coordinate -3, 6. And coordinate B here is at, let's see, it's at 3, 0. And then we'll just find the three lines in any form we want. I'll do point slope form. And what I'll do for point slope form is I can pick any of the two endpoints as my point for point slope form, but it's easier if you use a coordinate that's got a 0 in it. It's just going to make the math a little bit easier to do. So given the choice of 6, 6, here or -6, 0, I'm going to choose -6, 0. Given the choice of -3, 6 or 12, 0, I'm going to pick 12, 0. These both have zeros in them, but I'm going to use this one because I know the y-intercept, and I can just write it in y-intercept form, slope-intercept form. All right. So let me find the three slopes of these lines. So QC, so the slope of QC is equal to, let's see, the change in y, it rises 6, and it runs 12. So the slope there is +0.5. The slope of AR, let's see, the rise, it goes down 6. At the same time, it goes over 15. So the slope there is -2/5. And lastly, the slope of SB, let's see, from S to B, it goes down 12 and over 3. So -12 and over 3. So the slope there is -4. Okay, move this over here. All right, so let's find the equations of these lines. So AR is going to be, let's see, AR. So AR, the equation for AR is going to be y minus 0 is equal to -2/5 times x minus 12. The line QC is going to be y minus 0 is equal to 1/2 times x plus 6. And lastly, SB is going to be y equals -4x plus 12. Now, I can simplify QC a bit. I can make this y equals 1/2 x plus 3. And to find the intersection, I'm going to pick the two easiest lines to find the intersection of. And the two easiest would be QC and SB. And what I'll do is looks like I'll just set them equal to each other. And if I do that, if I set them equal to each other, I get 1/2 x plus 3 is equal to -4x plus 12. Which gives me that 9x, that's not right, it gives me 9 is equal to 9 halves x, which tells me if I multiply both sides by 2 9ths that x equals 2. And if I plug that into either of those equations, I'll get y equals 1 plus 3, which is 4. So that tells me the intersection there is the coordinate 2, 4. And to show that this is the intersection of all three lines, well, all I need to do is plug it into this equation. And if 2, 4 works in this equation, then I'm all set. Give myself a little bit of room. Okay, I'll plug 2, 4 into AR. And if I do that, I get 4 minus 0 is equal to negative 2/5 times 2 minus 12. So that gives me 4 equals negative 2/5 times negative 10. And then I get 4 equals 4. So it checks. So there we go. So we have found that the intersection there, they call it point G, the intersection of the three medians is indeed the point 2, 4. All right, well, number 37 asks you to find the intersection of the three perpendicular bisectors of the sides of triangle QRS. And so, in order to do that, well, the first thing you need to do is use those midpoints we found on number 36, the midpoints of the three sides. And the midpoints, again, were 6, 6, 3, 0, and negative 3, 6. And then we need to think about the slopes of each of those lines. Well, they're each perpendicular to the sides, so we need to know the slopes of the three sides of the triangle. QR is an easy one. That slope is 0, which means the slope of its perpendicular bisector is undefined. But undefined slopes are really, those equations are really easy because it's just going to be x equals 3. So there's one of my three perpendicular bisectors done. The slope of QS, well, QS rises 12 and it runs 6, goes up 12 and over 6. So the slope of this line right here is equal to 2. The SR, on the other hand, goes down 12 and over 12, so its slope is negative 1. Which means the slope of this line here is is 1. It's the opposite reciprocal. The slope of this one here of A, well, I don't know what the perpendicular bisector of QS, its slope is equal to negative 1/2. So let's write these equations. We've got one of them. X equals 3 is one of them. So there's one of the three equations. This one here, it turns out to be really, the one through C is really easy because it goes through 6, 6. It's got a slope of 1. So it's just y equals x, which at this point we kind of know where that intersection has to be. Has to be at the point 3, 3 if y equals x. Because that's contained in both of those. And let's find the equation of the other perpendicular bisector. Well, it goes through negative 3, 6, and it's got a slope of negative 1/2, so it's going to be y minus 6 is equal to negative 1/2 times x plus 3. And to see that this works, let's plug in the point 3, 3, because if we plug in 3, 3, we should get a true statement. And if we plug in 3, 3, we get 3 minus 6 is equal to negative 1/2 3 plus 3. So on this side we get negative 3, and on this side we get negative 1/2 times 6, which is negative 3. So it checks. So there we have it. 3, 3 is the intersection of the three perpendicular bisectors of this triangle. So one interesting thing to think about that coordinate 3, 3 is that it is the since it's the intersection of the three perpendicular bisectors, and every point on each perpendicular bisector is equidistant from the two endpoints of the segment that's being bisected, this coordinate here is the same distance, is equidistant from S, R, and Q. So that is the center of the circle that this triangle would be inscribed within. I didn't draw the circle very well, but that these distances, any of these radii, would have to be congruent. And if you draw the radii in, you can kind of see that since this is perpendicular and this is a midpoint, and this is perpendicular and this is the midpoint, and this is perpendicular and this is the midpoint. If you think back to first term, we've got lots of congruent triangles. This triangle here is congruent to this triangle here, so this is congruent to that. You can prove all sorts of things going on here. So there we have it.